Hello students. So in our earlier videos we have seen various types of loop structures in C: for loop, while loop, do while loop. So today we'll study two important statements which are called break and continue statements, which are also used inside the loop but for a different purpose. The break statement is used as an early exit from the loop. Sometimes it is necessary to exit from the loop if some condition is satisfied, or even unconditionally. So in such situations we will use the break statement. So here, as you can see, an early exit from the loop can be accomplished by using the break statement. So when a break statement is encountered inside a loop, the loop is immediately exited and the control is transferred to the statement immediately following the loop. So when loops are nested, the break would exit only from the loop containing it. That is, the break will exit only a single loop. Thus the break statement is used to jump outside a loop. The format of the break statement is break followed with semicolon. And the continue statement does a similar work but in a different way. During loop operations, it may be necessary to skip a part of the body of the loop under certain conditions. So the continue statement causes the loop to be continued with the next iteration after skipping any statements in between. So the continue statement tells the compiler that skip the following statements and continue with the next iteration. So the format of the continue statement is continue followed with semicolon. Okay, so let us see one program in order to understand the break and continue statements. This program, as you can see, so it's a program just to illustrate the use of break and continue statements. So we need a loop structure here. Suppose we are executing a loop structure with I equal to 1, I less than or equal to 10, I plus plus, right? And so there are two loop structures that we have written, one with break statement, another with continue statement, to understand the difference between these two statements. So with break statement at I equal to 5, so the loop starts with I equal to 1. So and inside the loop there is a test condition that if I is 5, then break. That means when the value of I becomes 5, immediately the loop will be exited. So the loop execution of the loop will stop. It will not go to the next iteration, right? And to just keep and watch on what the loop is doing, for that we need this printf statement. So when I equal to 1, this condition is not satisfied, I equal to 5 is not satisfied, so it will not break, it will just print I equal to 1, and the value of I will become 2. So 2 is not equal to 5, so break statement won't be encountered, so it will print the value 2. So it will print up to I equal to 4. So when the value of I becomes 5, then the break statement will be encountered and immediately the control will go outside the loop and it will print the loop stops as soon as the break is encountered, right? And with the continue statement, what is the difference? Difference is this: for I equal to 1, the continue is not encountered, so it will print the next statement. For I equal to 2, 3 up to 4, the continue is not encountered, so it will keep on printing 1, 2, 3, 4. When the value of I becomes 5, the continue statement will be encountered. So what does it mean? That whatever statements are there after the continue statement will not be executed. So you will see when we run the program, when the value of I becomes 5, the continue will be encountered and the value I equal to 5 will not be printed here. Instead, the control will go to the next iteration. That is, the value of I will become 6, and from 6 onwards up to 10, everything will be printed. So break statements stops the execution of the loop completely. Continue statements skips that particular iteration and continues the loop from the next iteration. Okay. So yeah, so let us see how this program runs. So dot slash program 20 brkcnt. Okay, so this is the program. Use of break and continue statements. So you see, with break at I equal to 5, the loop runs from I equal to 1 to up to 4, but when I becomes 5, the loop is exited. The loop stops as soon as the break is encountered. And with the continue at I equal to 5, 1, 2, 3, 4, and when the value of I becomes 5, the next part is not executed. The statements below the continue statements are not executed, and hence I equal to 5 is not printed here. So the iteration starts from the next value, that is I equal to 6 onwards. So this program illustrates how the break statement and continue statement differ from each other. Okay, so let us have a look at a program to print to test whether a number is prime or not. Say this program, you can see what is this program. This is a program to test if a given number is prime or not. So we start with hash include stdio.h, hash include math.h. This will be required here because we will use one square root function. So void main int ni, printf, enter a number. So scanf %d %n. So if n is 1, then it will print that it is not prime. If n is 2, then it will print that n is 2 is prime. And for other values, we will just make use of this logic. We will keep on dividing the particular number n by successive numbers till up to square root of n. So there is a theorem from number theory: if a number is not divisible by any number up to square root of n, then the number is a prime number. So we will be using this theorem here. So for I equal to 2, I less than n, I plus plus. If so, here this I less than n, this is also not required. We do, because we will give the condition for exiting the loop here at this position. If I is greater than square root of n, then the loop will exit, right? So we don't need the condition I less than or equal to n here. So we will keep it as empty. So for I equal to 2 and semicolon, then I plus plus. If n % I is 0, if n is divisible by I, then immediately we can say that n is not a prime number. So it will print that n is not prime, and it will break. So it will break from this for loop. Means we have already got our conclusion. Otherwise, if it may happen that it is not divisible, and if it is, in case it is not divisible by I, it will check whether the value of I is greater than square root of n or not. If it is greater than square root of n, that means the number is not divisible by any number up to square root of n. So we can come to the conclusion that the number is prime number. So after that, again we will use the break statement. That means we don't want the loop to continue again. Okay. So this is the, so please note the brackets. There are lots of brackets here. That is why indentation is very necessary. The bracket for else, it ends here. Bracket for this for statement will end here. Bracket for if will end here. Bracket for this else if will end here. And the last bracket is the main statement bracket, which ends there. So that is why it's very important to write the indentations. So let us see how this program runs. Dot slash prime. So enter a number, say 2, it will just print 2 is prime. Say enter a number 6, 6 is not prime. Enter another number, say 97, 97 is a prime number. Okay. So you can enter many other numbers which it will say whether it is prime or not. Okay. Another program that we can see is to display all prime numbers less than some given number. Okay, let us see how we can write that. This program to display all prime numbers less than a given number. Okay, these are the things. So int n ij, so display all prime numbers less than what, which value. So that value is n, which will be entered by the user. So we will display here the prime numbers less than n are. So 2 will be displayed automatically. We will start the check, we will start the division process from I equal to 3 onwards. Yeah, so for I equal to 3, I less than n, I plus plus. For j equal to 2, so we don't need any condition here. So for j equal to 2, j plus plus, if I percent j is 0, then break, that the number is not prime. So we will just break from the this. So this break will exit only from the inner for loop. This break statement will make an exit only from the inner for loop. It will not exit from the outer for loop. Okay. So if I percent j is 0, then we will break. Else if j is greater than square root of I, then we are sure that it's a prime number. So we will print it out. Okay, and after that again we will break from this particular inner loop. Okay, so here also you have to note the brackets. The bracket for this, the brace for this is ends here, brace for the second for ends here, brace for the else if ends here. Okay, so let us run this program and see what happens. Display all prime numbers, say less than 10. So prime numbers less than 10 are 2, 3, 5 and 7. Okay, display all prime numbers less than 100. Okay, so 2, 3, 5, 7, 11, 13, 17. Okay, like that up to 97. So that's how the program runs. So here we have made use of the break statement. Okay. So this was about loops. So in the next video we will start with the chapter on arrays and writing programs on matrices, addition, multiplication, subtraction of matrices, etc. Thank you.